Okay, guys. So today you guys are doing absolute value functions. Right here you have our standard form of writing. It's in vertex form. We have x minus h, absolute value of x minus h plus k, and the h comma k represents the vertex. You're going to graph the function and analyze the domain. So the first thing we do when we graph is first we're going to graph the vertex. Okay, remember we said that vertex is h and k. So this is our h, this is our k. So therefore our vertex is going to be at 1, -1. And I know you're probably like, oh wait, this is negative. No, one thing we need to remember is our x's are liars. X's lie. So even though it looks like a -1, it's actually a +1. So we're going to graph that first, 1, -1. So we go to 1, go down to -1, and that's our first point. Okay. The key thing to remember about absolute value is that they are symmetrical. So if I know one, then I know the other. So we're going to substitute in to find our when x equals 0. So we can have another point. So we're going to substitute in for x equals 0. So when I substitute in for that, I get f of 0 equals 0 minus 1 minus 1. So 0 minus 1. Yesterday you learned that when you have the absolute value of a negative, it's going to make it a positive because all you're asking is how far is -1 from 0? And that is 1. So then I'm left with 1 minus 1. And 1 minus 1 equals 0. So at 0, I'm going to go to 0. Okay. So now we have that second point in. And remember that they are symmetrical. So if absolute value are symmetrical, there is an imaginary line of symmetry. So if I know one point, then I know the other. So on this side, we have that one, right? And then from here, I can use where absolute value is made up of 2 lines. So if I wanted to be more accurate, I would just use slope. So how much do I rise? How much do I run? I rise 1, run 1, rise 1, run 1. And I can figure out the other points by finding how much I'm going. Rise 1, and it's just going. And it keeps going, and it keeps going. And then now I can connect my lines. Now pretend that these are perfectly connected. That is not bad for me. I'm going to connect, and then draw my arrows to show that it goes on forever. And that's how we graph, okay? So step 3, what do? We use the slope to finish the line. So we use rise over run to finish. Okay. Then the last thing it says, what is your domain, your range, and your intercept? So your domain, well, the domain of all absolute value functions, because they go forever to the left and forever to the right, your domain is going to be from -infinity to positive infinity. Or we can shorthand say all real numbers, okay? Your range is from bottom to top. So what's the lowest y value we have? Our lowest y value is down here at -1. So we start at -1, but it goes forever to infinity. So it goes on forever. So -1 to infinity, okay? And then last but not least, it says, what are your intercepts? Your intercepts are where do you cross the x and y axis? Okay, so we cross the x and y axis. Let's identify where. We cross y right here, and our x right there, and our x and y right there. So therefore, our intercepts, I forgot a letter in there. There you go. Our intercepts are at 0, 0. And here we were at 1, 2, at 2, 0. And that's how you analyze. Okay, so we find the vertex. We plug in x equals 0 to find our first point. And then once we found that point, we reflected it over our axis of symmetry. And then we just used our slope, rise over run, to find the remaining points. Okay. Okay. So then now let's look at this one. So notice here, this says f of x equals the absolute value of x plus 4, but you don't have a number on the outside. When there's no number on the outside, that means it's plus 0, okay? So we're going to go through the same steps. So the first step is to identify our vertex. Our vertex here, again, we have our H and our K. Now, remember how I told you earlier that our X is a line. So it looks like it should be a +4, but it's actually a -4. Okay, so our vertex is at -4, comma 0. So I'm going to go to -4, 1, 2, 3, 4, and I'm going to stay here. That's our vertex. So that's our vertex, and it's our axis of symmetry. Okay. Now that I have that, I then am going to find x equals 0. So I'm going to find what is x equal to 0. So x equal to 0 means that I'm plugging in f of 0, which equals 0 plus 4. Okay. 0 plus 4 is absolute value of 4. Absolute value of 4 is just 4. So at 0, I go to 4. 1, 2, 3, 4. Okay. Now, remember, axis of symmetry means that the points are the same distance from this line on both sides. So if this one is 1, 2, 3, 4, then its counterpart is going to be also 4 ways. So 1, 2, 3, 4 is my other point. Okay. So then now I can connect the lines. If I want to be more accurate, I would use rise over run. And they keep going. So from looking here, I can find the domain and range. And again, the domain for all absolute values is from -infinity to +infinity. Excuse how weird that looks, which means that it's all real numbers, okay? Our range is from what is the lowest we go? Well, the lowest we go is at 0. So we go down to 0, and then we continue to infinity. Okay, so that's your first page. Now we're going to flip over. Okay, so on to example 3. So example 3, it says the graph of f of x equals negative absolute value of x plus 1. And so we're going to graph it and analyze it. All right, so here we go. So we're going to graph the function again. This time it says that there's a little hiccup here. There's a negative in front, okay? So if there's a negative in front, that is okay. We are going to, oh, sorry. This is the one we're supposed to practice graphing in the calculator. So graphing in calculator. Okay, but since there's a negative in front, this lets us know that instead of us having a happy absolute value, this is when it's a positive in front, we're going to have a sad absolute value because there's a negative in front. So let's go to our calculator and graph this. So in the calculator, I'm going to turn on my calculator. I'm going to clear my calculator because I have a bunch of other stuff on it. So I'm going to graph this. So to graph this, I'm going to go to y equals, and I'm going to press negative, not minus. This is a minus sign. This is a negative sign. So I'm going to press negative. To get absolute value, we're going to press the button called math. Okay. From the math button, you have to arrow over and you see where it says ABS, abs. That stands for absolute values. We're going to press that. And now we're going to press our variable key. Sorry for the bell. We're going to press our variable key right here, this X, and it's going to put it in there. So now we have the absolute value of X and then plus 1. Okay. And it says we're going to graph it and analyze the maximum and minimum on the interval from -2 to 3. So I'm going to hit graph. And notice how I told you this time it was going to be a sad absolute value. There it goes. But it says it wants us to look from the interval from -2 to 3. So because it's giving us restrictions on where we're going to look, that means we're going to change our values. So again, let's write what we did. So we went to y equals. So using the calculator, 1, you're going to press y equals. And then once in y equal, we're going to input the function. So we input f of x. To get absolute value, you have to press math. And you're going to arrow over to num. and then you're going to press 1. And that's the ABS. And that's what we did. So to get the absolute value, that's how we got here. Now we press graph. And it wants us to look on the interval from -2 to 3. So we're looking from -2 to 3 only. So when we want to look from -2 to 3, there's a couple ways of doing it. But the easiest way it's going to look is you can zoom in and you can see from -2 to 3 what's happening on the interval. So I'm going to zoom in, see where it says zoom in. Just want to zoom in a little bit. I press zoom. And now I zoomed in too much. So I can see -2, but I can't see +3. When things like that happen, you can change your window yourself. So if I want to be able to see from -2 to 3, let me go to 4.5. I can type in what I need and the calculator will show me, okay, here's from -2 to 3. And it's asking on the interval from -2 to 3, what is my highest value? Value meaning your Y. And what is my lowest value? So looking here, we can see, we can trace the graph. So if you press trace, you can go like this and it'll let you trace the graph. So we can see here, if I go over here to -2.
Good morning, Waco High. Teachers, did you give the students a minute or two to get into class?
Okay, so if you see this, you hit trace, it allows you to trace the graph. And also you can, once you're in trace, you can press the number and it will take you there. So at -2, I'm at -1. I can type in 0 and it'll tell me, oh, you're at 1. I can type in 3 and it says, oh, you're at -2. So looking at this from this interval, my maximum value is at 0. If I type in 0, it gives me the highest value of 1. So my maximum is at 0, 1. So we're going to write that down. So once we graph, we then use the trace button to find values. Okay, so our max is at 0, 1. Now we're looking at our min. And our minimum value is at, from over here. When we typed in 3, it took us all the way down here to -2. And -2 is our lowest point that we can see from -2 to 3. So we're going to say that our minimum is at 3, -2. So at x equals 3, we have a minimum of -2. Okay, and that's what it's wanting you to do. So when we graph what we have, so I'm going to put here, so we're at 0, 1 is our vertex, which makes sense because our vertex in this case is our highest. And we had 3, -2. So I can go over here, 1, 2, 3, down 2. So the same thing over here. If I went over at 2, we had, what was our 2? We had -1. So if we type -2 in again, let's just verify. It was at -1. So go over to -2, -1, and this is what our absolute value looks like. Okay, just for reminders, looking here, the domain again, even though it's negative, it's still going to be all real numbers from -infinity to +infinity. The range is different now. The bottom, we go all the way down to -infinity, but we come up to 1. So it's in reverse. So it's our -infinity, because that's what's down here, right? And then we come all the way up to 1, and that's where we stop. Okay. All right, the last piece of your notes is a real world problem. So it says here, a ride at an amusement park carries passengers along a vertical tower to give them a view of their surroundings. During a test run, a park employee records the height of All right, a ride at an amusement park carries passengers along a vertical tower to give them a view of their surroundings. During a test run, a park employee records the height of the ride for 10 seconds. The function they came up with is the absolute value of x minus 5 plus 4.8. Models the height f of x of the ride in meters after x seconds. Graph the function and interpret the domain range. Interpret the domain, range, intercept, symmetry, and maximum and minimum value. Okay, so here we have absolute value of x minus 5 plus 4.8. Because this is a real world example, notice how we're only in quadrant 1. We only want positive x's and positive y's. So we're going to go to the calculator and graph, but we're going to switch our domain because it says it's only from 0 to 10 seconds, right? And we want to know what's happening as we model this. So I'm going to go to the calculator. We're going to go back to our y equals, and we're going to, this time we're graphing absolute value of x minus 5. So math number 1, x minus 5. And then we're going to arrow out because we're done on the inside. And then it says plus 4.8. So plus 4 and 8 tenths. Okay. I'm going to graph, but remember that my graph is set into like weird things already because I was already graphing something. That's okay. We're going to fix it because we need to change our graph. So reset, anytime you need to reset your graph, you go to zoom and you see where it says standard. Zoom standard is going to reset your graph to the original view. So notice how I went pew pew. Okay. All right, but we only need quadrant 1, and we only need it from 0 to 10 because I only need quadrant 1. That means my lowest value that I'm looking at is 0. So in my windows, my x min is going to be 0. I like to go a little bit more. So even though we know we need to go up to 10, I'm going to go one more to 11. My y min also needs to be 0. And I'll leave my x max there. How high do you think a ride would go? I don't know. Let's see. We'll go to 20 and see what happens. Okay. And now when I hit graph, it's going to show me only what I need to see. Does that make sense? So I'm now only in quadrant 1. So this is what we're going to plot. So you can hit trace and you can get values to plot. So if I type in 0, it says we're going to go to 9.8. So at 0, we're at 9.8. So 0. And let's count by 1, 2, 3, 4, 5, 6. I think we can count by 2s, honestly. 1, 2, 3, 4, 5, 6, 7, or halfway points. Yeah, let's do that. So this is 1, 2, 3, 4, 5, 6. My old eyes are getting the best of me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, okay, I did it. 10, 9, 8, 7. All right, there we go. And so we're at 0 and 9.1. So for this one, we're going to go to 0, go up here to 9.1, which is closer to 10. Not at 10, but close to 10. Okay. Now we're going to go back to our calculator, and we already pressed trace. So trace allows us to find other values, but we also can use our table. So if I go to second graph, I can look at the table and find values. So if I look at the table here, I know that 1 is 8.1, 2 is 7.8, 3 is 6.8, and I can see 5 is 5.8. I see the values, and it makes it a little bit easier to graph. So I'm going to just do the vertex, and the vertex is at 5 and 4/8. So we have 1, and how do I know that? Because it says right here 5 and 4/8. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to go to 5 and 4/8. So up 5, 1, 2, and over 5, 2, 3, 4, and then 4/8. Okay. And then I'm going to mirror it, and I'm going to kind of like graph it. Oh man, these have been some of the straightest lines I've ever made, by the way, guys. We're going to pretend that these are all perfect. There we go. So it wants to know for us to graph the function and interpret the domain and range. So the domain here, our domain is only from 0 to 10 because how long is the ride? 10 seconds. So it goes from 0 to 10. Our range is what's the highest they go and what's the lowest they go. Well, the lowest the ride went was here. And that was at 4.8. The highest the ride went was, let's double check. I think it was 9.8, right? From 10, yeah. So the highest at 10 was 9.8 and at 0. So the highest it went was 9.8. Because real world, does things go on forever? No. Intercepts. The only intercept that I have is a y-intercept. And our y-intercept is on the y-axis at 0, 9.8. That's because the ride starts up that high and then it drops you, right? And then our symmetry, we do have symmetry. Okay. It has an axis of symmetry, and our axis of symmetry is at x equals 5. But in terms of symmetry, whether it's even or odd, it doesn't have any even or odd symmetry. It's only symmetrical around a point. And our maximum and minimum, our max value is 9.8. And it's at 2 locations, at x equals 0 and x equals 10. And our min value is 4.8. And it's at x equals 5. Okay. All right. And there's our real world example. So after doing this, your job is now to summarize, what do you think domain is? What do you think range is? Intercepts, axis of symmetry, max and min. So in your own words, and then we'll check back. All right. Thank you.